Hello, it's Bill Manuel again. And today I want to talk a little bit more about cosmic event horizons and also holographic horizons. Now, the holographic principle was created by Juan Maldacena and Leonard Susskind, and it says that any 3D region of space can be defined by its boundary. So, we were talking about how gravity emerges from entanglement from the previous videos, and then we saw that there seemed to be a little extra efficiency. We were expecting 0.707 for the gravity being emitted through quantum mechanics, but we saw 0.724. Well, then I started realizing the relationship between curvature and the amount of energy that's contained in quantum entanglement, like the quantum logic. And what I found was that the amount of gravity is equivalent to the energy level in the quantum logic bit. So I wanted to find out where that extra 1.7 efficiency came from, and I decided that it was probably from the curvature of our cosmic horizon. So our cosmic horizon right now is at 13.8 billion light years. That's what we see, and that's the horizon that we interact with. That's the horizon that projects our 3D reality into our space. Now, the way this works is this is relative holographic horizons. Every object, every observer has their own holographic horizon that follows them around all through their journey through space-time. And these horizons interact with each other to spread quantum information, but the gravity of these horizons has an effect in 3D space. This is key. This makes it different than Maldacena's idea. Because in my idea, actually, these event horizons cause dark energy. We see that the negative curvature of a universe of the cosmic event horizon causes that extra efficiency of 0.017. So we find that curvature is intimately related to how quantum communication occurs. Now, I'll give you an example of how this emerges as dark energy. Let's say that we see an object very close to our holographic horizon, our relative holographic horizon, and they're very close to that wall of information that's gravitating relatively to our position. And we see that these distant objects are gravitated right out of our universe. Now, this is not just an artifact. This is what happens because if you go to that galaxy that we saw leave, and you look at what they see that nothing's different. They're not close to an event horizon, but it's us, the distant people in Milky Way, who are getting ready to leave their event horizon. So the fact that they're leaving ours and we are leaving theirs basically explains dark energy. And this is going to change the way people view reality. It's looking like the holographic principle is a relative holographic principle, and it serves to restrict data. And as you're moving, you're having to encode all the other horizons' quantum information onto your horizon, and this is where length contraction and time dilation occur as the horizon is attempting to update at the speed of c to accommodate for your movement. So this is a very new way of looking at things. It's a relative horizon that only exists very far away. Now, our universe appears to have most of the information's already crossed. Our event horizon has some quantum mechanical information, but it also has mostly gravity information from all the objects it already left. So it has a bunch of extra gravity bits, so if it needs a gravity bit to project down into our 3D space, it's no problem. There's more than enough left. This also suggests that our universe has expanded just about the size it's going to. Even if all the rest of the information goes across this event horizon, the event horizon isn't going to grow that much from 13.8 billion light years. So probably over 99% of all matter has crossed already, back when our cosmic horizons were very small and very energetic time. And now it's just expanded to almost its full accounting of everything that crossed our horizon, and that's why we have the dimensions of our universe that we see. However, this doesn't mean that that's just the extent of the entire universe. This is a relative horizon. It could be that these relative horizons stack up for a very long distance, and we're going to have to probably check into the data and maybe look for some harmonics to maybe uncover the entire size of the universe. It may be possible, I'm not sure yet. That's an avenue I'm going down right now to see if we can kind of glean the overall size and structure of the universe. But the relative horizons are looking very promising for explaining a lot of things. And make sure to watch my other videos. Please read the descriptions. If you have any questions, please post them. I will do my best to answer them. If the answer is going to take too much text space, I'll just create a video, and you can watch the answer via video. So thanks again, and remember that this science thing is not just for people in ivory towers. People like us, we can go and search these things out ourselves. The internet has almost the entire compendium human knowledge on it, and we don't have to wait for someone in an ivory tower to pick up a pen and try to look at our ideas. We have the ability to chase our ideas down through all of the information that's freely available. We don't have to wave a piece of paper anymore saying that you have to listen to me because I have a piece of paper. We've got the math. The math is down. Anyone that can do that math can prove it themselves, and they will see the same answer. It just is what it is. It's a very elegant explanation. It solves a lot of issues, and thanks for coming with me on this journey. It's been a real eye-opener. I really feel that I've got a much better understanding of how the universe operates, quantum mechanics, relativity, just so much. It's a crazy time. Thanks again.